Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Autonomous Drone Mode 0 to Hero special series to build your robotic flying machine. Yes, drone is also called as a flying robot, right? Anyway, so guys, as I explained in the previous video, we did a basic setup, using a small acrylic, play card, and stuck our PixHawk and GPS and the buzzer and the switch and stuff like that. I hope you guys are ready with this setup. Now, as I explained, I'll be sharing another video prepared by a gentleman from Painless 360 in the UK who's an expert in PixHawk, and I personally learned a lot from his videos and tutorials. So I try to do practically myself. So in this lesson I will show you how to hook up your PixHawk to Windows machine for initial configuration using Mission Planner software. Of course, we are using that gentleman's video side by side, and along that side I will be building. So you can watch me doing along with that gentleman's Painless 360 video as well. So the Mission Planner software, which is basically a full-featured GCS supported by ArduPilot. What is GCS? It's a ground control station. GCS stands for ground control station. So I hope you guys watched one of the earlier lessons where I showed you all the terminologies and acronyms used in the drone industry. So go ahead and take a look. It's basically the skills you got to develop, guys. So ArduPilot basically offers a point and click interaction with your hardware, right? When I say hardware, it's about PixHawk, it's about the microcontroller which is PixHawk, right? And of course there's a custom scripting and simulation which we will be doing at a later stage. So these hardwares is the peripheral sensors, controller and output devices that act as the vehicle's eye. Vehicle means it's your drone, right? Your drone's eyes and ears and brains and arms, right? So that it's basically the entire control mechanism. It's a control system, right? Almost any kind of mobile machine can be transformed into an autonomous vehicle by simply integrating a small hardware package into it. Now when I say hardware packages, again it's a PixHawk controller, right? So using inputs from the sensors, the control is able to, the PixHawk is able to send outputs to devices such as your ESC, sorry, it's your electronic speed controllers and servo motors or brushless motors, your gimbals, that is your pan and tilt for the cameras, right? LiDAR, when we connect LiDAR, that's going to communicate along with a parallel communication with your single board computer and PixHawk, right? And single board computers like Jetson Nano or Raspberry Pi, we will be using Jetson Nano and Raspberry both, right? I'll show you how to plug it in. We will also use Intel D435 Depth Camera and other peripheral devices which is supported by PixHawk and Jetson Nano and Raspberry Pi. Now firmware, you might also hear this word again and again, firmware, especially when you're going to watch this video from Painless 360. Firmware is nothing but a code running on the controller. It's a ton loads of pre-built code which comes along with your Mission Planner application which you downloaded in one of the previous lessons, and you choose the firmware to match your vehicle and the mission. When I say vehicle, again it's a drone. You might be building a quadcopter with just 4 wings, and you might be building a hexacopter or which is with 6 wings. You might be building a 8 wings. So based on that, the software will change. That is the firmware code will change. So in this lesson you are going to see how to select the correct firmware. It can be a copter, it can be a plane, it can be a ground rover bot, or it can be a submarine below the sea, or any other kind of robot which you want to build using PixHawk, right? So software is basically your interface to the controller, the firmware or the software you can call it. It's an interface to the controller, and that is also called as the ground control station, GCS, which is the Mission Planner, of course, right? So enough of my explanation. I'm going to go ahead and play that video, and also I'm going to start building it side by side. It is the same setup which you saw in the previous lesson, so I'm going to show you how practically I am able to do it watching other videos, and you will be able to do it watching my video, and it's going to be straightforward and simple. So as you can see, even this gentleman is using a small cardboard, something like this. What I'm using acrylic, and he's using a small cardboard which he has fixed. Your PixHawk on top and GPS mounted with the correct direction pointing towards this arrow. And yeah, so now let's see what it does. So keep watching the video, guys. It's going to be pretty interesting. We will actually see how to connect to Mission Planner and do the calibration and the configuration stuff and installing the firmware. It's pretty simple though, but for the first time, for the beginners, it's very important to go through step by step. And that's the switch, right? That's the switch which is showing up. There are different varieties and models. The one which I have has got a small LED sensor at the bottom and the switch on the top, but never mind, it's all one of the same. Of course, he has connected the receiver, which I haven't done. So receiver basically goes in here in one of this junction RC. It's written as RC at the last point. I will create a separate lesson for transmitter and receiver. For now, for calibration and loading the firmware, I think this should be sufficient. Now let's open the mission planner. He is opening up in his video. He has opened up the ArduPilot site, and which I showed you in the previous lesson, how to download the mission planner and stuff like that. I hope you guys are ready with the mission planner. So keep that ready. And that's exactly, he's going to show you now how to plug it in and do the configuration. Painless 360 production, and he has opened up the mission planner on his screen. So I hope you guys are ready with the mission planner. Now it's time to hook up to your USB, micro USB to USB. And there you go, you can see the green lights and the blue lights. It's actually here. There are few lights here. The main LED light is here just below the arrow, and there are a couple of other LEDs which are mounted within the box, within the PixHawk box. And on the screen you can see, you want to download the Windows driver. Well, I would suggest go ahead and download the drivers as well. And then you can see the light glowing on the switch. You might see, this is the switch, you can see the light glowing. And the receiver, if you have hooked up your receiver to the RC channel, I haven't done it, you might see the lights, the LEDs glowing on the receiver as well. So the entire setup takes the power from your USB port itself, from connected to your computer. Now on the mission planner, you got to go to the install firmware, click on install firmware, and you can see that screen, it installs the firmware. You can select your COM port, and it's very easy, guys. It seems like those of you from Arduino background, you know this stuff. I am using Hexacopter, so I'll be selecting the 6-wing model. He is choosing quadcopter, which is the 4-wing model. So you may choose according to the design you have, which frame you are using, and how many wings, how many motors, how many propellers. According to that, you have to select your firmware. Alright, now make sure that on the corner side you can see the two cables, right? It has to be in a disconnected position. And you can see the GPS coordinates, it's flashing. And on the left hand side, kind of the cockpit, you can see it is written as disarmed because it is not connected, right? So we are just calibrating in locally. So it has to be disarmed always during this process. And that is the accelerometer calibration. Calibrate, and you can see how it's going to move the device. You have to move it in the left hand, according to the direction left, so you have to keep it like this. And then like this, 90 degree exactly. I mean, you cannot measure exactly 90 degree, but you can just use approximate gesture. And then nose down like this, and then like this. And then fully upside down. And done. Once the calibration is done, you can keep it down. And you can select go to compass and select PixHawk PX4. And you can see that blue LED glowing up. Once you select PX4, it's going to send a pop-up message. You can click yes. And now you need to rotate this in all the directions to calibrate your IMU, right? So you got to do this till you see the white dots on the screen, which has to flow over in all the colors. You can see blue, green, red, and there are white dots. So the white dots has to basically go all over. So for that you need to do like this in all directions. And done. You can see it on the screen. You can click OK. And this is basically your radio calibration. So we haven't connected our receiver yet. So I'm going to make a separate video for the receiver. So you will get a clear idea in terms of how to hook up the receiver and stuff like that. So in that video I'll show you connecting the receiver and the transmitter, and then how we can calibrate using the mission planner and stuff. But make sure that is not connected to your drone, right? Not to connect the motors yet. We are not ready yet. So guys, keep this setup and the calibration ready. In the upcoming lessons I will show you how to do the further setup. There are a few more setups before even we start plugging in our propellers and motors and stuff like that. Once we are done with all this setup and do the first flight test, right, the hovering and the lifting and forward left, your drone should move, right? After that we'll have to slightly modify the circuit. Why? Because we will be adding Raspberry Pi or even Jetson Nano to start building your autonomous stuff, right? So that's where your Python scripting and stuff are going to come into picture. That's going to be level 2. Alright, I'm going to be back soon, guys. Hope you enjoyed. Do give me a like and a thumbs up. I'll be back soon. Goodbye.